Just to remind you then, or to remind me, what does f of x mean?
Oh.
Function of x.
And what does that actually mean?
What x is and what x does in the equation.
What x does?
What to substitute
the value of
f
it.
for in the equation?
The value of x.
It pretty much
No,
gives
it does,
x. It gives x like a
Oh, like f of x.
What you do
What
to
is
x
it
is what I was saying. It's what you do to x. The function that is applied to x. That is what f of x means. So if I say, I know we talked through this before. Troubles. If I say to you f of x equals, but if I ask you to tell me, give me a linear function.
F of x equals.
Go on.
Y equals mx plus b.
No.
That wouldn't make sense.
It wouldn't.
F
You're right.
equals 1 over 2, like that's the slope.
1 over 2. Keep it simple.
Yeah.
I'm not asking for a hard one.
Slope.
So if I ask for a linear function,
Was that right?
you haven't finished yet.
Equals 1 equals 1 over 2 m.
Nope.
No, x.
F of x equals
Well, you know,
8
for instance, a
8x plus 4.
okay, I'll go with that. A linear function you have seen in a different form. You have seen it as y equals mx plus c. That's what you're saying, yeah. So you knew the linear side of it,
Yeah.
but this is using y and x. What would I be doing if I wanted y equals something x?
Y equals something x or x equals something.
Yeah, but why would I be using a y equals? So for instance, I could have f of x equals 8x plus 3. If I wrote it like this, I would have y equals 8x plus 3. What's the difference between the two things?
One you're using the function of x, and the other you're trying to find a line on a graph.
Okay, so it's the same thing. 8x plus 3 is the same thing. All right? You substitute a value of x in, and you get a number out. Yeah? So you've got an input and you've got an output. So in this case, x is my input, and the output after we've done f of x is 8x plus 3. Yeah. All right?
So that's like.
So that's
But if I said x is the input and I apply the function to x, what comes out?
Pardon?
What comes out in this case?
Why? 8x plus 3.
Yeah, it's the same thing. We do exactly the same thing, right? But we are literally talking about written language now. Maths as a written language. So why would I want to have x and y? Well, because as Kieran said, maybe we're graphing the information. Okay? The only time really we have an x and a y is when what we want to do is show the relationship between x and y on a set of axes, right?
Yes.
Because that's the x and that's the y, and a point there is a coordinate, yeah? And the reason for having that coordinate is because you know that those two values represent the input and the output. Okay? Now, that doesn't change when we use function notation. We still have the input, we have an output. We just don't call it y. Because we're not necessarily graphing it. It's just a different way of writing the same thing. But everything you can do with the y equals something x plus something, right? You have the same situation. So function notation is used when we're doing sort of more pure mathematical manipulation of the function, and we're actually sort of just looking at the numbers and we're not looking at the shape of the function by graphing it. Okay? We can say, if f of x is 8x plus 3, I could say to you, plot the graph of y equals f of x. And what would I be saying? I want the graph of y equals 8x plus 3. Yeah? Right. So that's where we come from. That y and the f of x, they're interchangeable. People think of it that way. Yes?
So this is basically just like, f of x is basically just a way of substitution.
Yeah, it's just another way of writing the same thing. Yeah? But what we can do, for instance, is it's like having a shorthand. It's a way of writing without having to write everything out all the time. So, for instance, we need to understand what does f of 3 mean, and what does f of x equals 3 mean. Yeah?
Is there certain situations where it's impossible to use the y-intercept form and the only way you can is by using a function?
No, it's just a different way of writing. Like you could write, it's, you know, it's just a suitable way for whatever we're doing at the time. So if we're writing mathematics in a report and we're not doing graphs and things, you'll see function notation being used.
Yeah.
When we do what we're going to be looking at, when we do transformations of functions, we definitely would be able to understand it much better using function notation. But then we will transfer that into graphing as well, because they're the same thing, really. Yes?
So, like on a test, we would be given the value of fx, and then we would have to substitute it.
It depends. There's lots of ways that I could ask you. Function notation is just a different way of writing the stuff that you're probably already used to doing. So we did talk about this. If f of x equals 8x plus 3, what does f of 3 mean?
F of 3 was x.
8x equals 3.
Oh, 8. 8
Yeah,
times
the f
3
of 3
equals
is
8
Okay.
times 3 plus 3.
So it's
24 plus 3.
8 times 3 plus 3. So that is when we substitute for x. Okay, so you'll notice that the f of x now has a 3 instead of the x. So you are substituting 3 for where the x would be.
So it'll be like f of 3 equals x?
No, f of
Wait, no,
3,
because
what does f of 3 actually equal?
F of 3 equals
27.
27. Yeah?
oh, because it's 8 times. Oh, okay.
So I am substituting 3 into the function
So the y
to figure out.
27.
So what would be, yeah? So over here we'd be saying if y equals 8x plus 3, we would say y equals 27 when x equals 3. Okay?
Oh, okay.
What does f of x equals 3 mean? It means we have 8x plus 3 equals 3. So what am I asking you to do?
And then you just have to solve.
0. X is
Exactly.
0.
X.
X is 0.
Solve for x.
X is 0.
0. Yeah. So in this case,
So then when x is 0, y is 3.
so x is 0, and over here I would be saying, yeah, when x is 0, y equals 3. Over here I could write now f of 0
F of 0 is
equals 3. Okay?
When x is 0, y is 3.
So the difference is, the two things are, if I have the x has been replaced by a number, I'm substituting. If I have f of x equals something, I have to solve. Okay? So just tell me quickly then, if I write, so I'm going to do a new set of things. So f of x equals 2x minus 4. G of x is x squared plus 1. And h of x equals 2 to the power of x. Okay? If I said to you, I want g of 3 plus f of 1, okay, minus h of 0, what would I be asking you to do?
You would have to solve each of them to find out what they mean.
So you're asking me
By substituting.
okay, so we're not solving, are we?
Substituting.
We're
Value.
substituting to give each function a
Value.
value. Good. We've got to get this vocabulary right. Substitute for x to give each function a value. Okay? So just for vocab's sake, this kind of function is a what function? So that was a linear. This one is a no.
That's also
Nope.
oh, the square.
Quadratic.
Quadratic. Yeah. And this is a
Exponential.
exponential. Why is this one not an exponential, but this one is?
Because
the x is the actual.
Okay, so the variable that is the thing that you control, and we're going to talk about this information in a minute, what that's actually called. The bit that you control is the power, is the exponent in an exponential function. So the thing that changes is the exponent. Okay? In a quadratic, the thing that changes is squared. So you know the effect of the change is squared, so it's quadratic. In a linear, the thing that gets changed is only multiplied by a constant, so it's a linear relationship. Yeah?
So the number that you substitute in for x has no meaning. Like you can choose any number, right?
No, so what am I being asked to do here? G of x mean I'm doing 3
Yes.
squared plus 1
Yes.
plus
But
2 times 1 minus 4
yeah.
minus
Minus
2 to the power of 0.
Oh,
But,
so
you could do 2 to the. I was saying you could do like 4 squared plus 1, and then to solve it, and then 2 times 2 or whatever.
Yeah, if I wanted to pick any value of x,
So
but for this problem I've given you
it's
certain values.
It's 10
Oh, so the value will be.
It's 10 minus 2 minus 1, which is 10 minus 4, which equals something.
I got 10 minus 2 minus
So
0.
10
Oh, it is 1.
plus
Negative 2.
negative 2,
Take
take away 1, okay,
equals 7.
So 7.
equals 7 sort of x.
Interesting.
So that's a bit of a function later. Do you want to write that down? So I know you're not writing it. So I said solve g of x equals 10. I'm asking you to solve x squared plus 1 equals 10. So there if we subtract the 1, it's x squared equals 9. We then square root 9. And we get x equals plus and minus 3. There are 2 solutions to that. Yes?
I have a question. In the last one, 2 times 1 minus 4. The value was -2.
Yeah?
How does that equal -2?
2 times 1 is
That's 1 and 2.
Oh,
Two.
never mind.
subtract 4.
Two. Oh, yeah. Yeah, that's, I don't know what you're saying.
Happens to the best. Okay. Just because, well, actually, do you know what? I'm not going to go through what it says in the book. The book has a pretty obvious thing about f plus g of x. You can have a read of that. But the one thing I want to talk about, and then you can get on and do some of the work, 2 very, very important words for you now. Domain and range. Okay? Domain and range. And this can get more involved and more complicated. So, the domain and range of a function. Okay? So the domain of a function is all x values that are possible to use. Okay. Now, when I say the word possible, the domain, have you ever heard a saying this is my domain?
Yes.
What does that mean?
It's like,
My
that's your
art, my
place.
area. This is my district.
My
I
area.
own this.
I
This
own
is your
this.
place.
This is my, what happens here is my decision. Yeah?
Yeah.
Domain, the x values that are possible. So when you deal with a function, which number do you decide to use? The x. Alright? So the x is what you control. You pick the x. However, that can be limited based on what values are actually possible to use in functions. So some functions, you can use any value of x you wish. Some functions you can't. Can you already think of any function where you can't use a specific
Specific
number?
number for it?
Yeah.
In the
You can't
In an
do
exponential
the
form.
negative of the logarithm.
There you go. So you remember you couldn't put a negative in. So if I do the logarithmic function, I can't find log to the base 2 of negative. So if I add log to the base 2 of x as a function, I can't use negative values. So there is a limit. Sometimes. And sometimes there is a limit based on situation. If it is a cost function, so it's cost based on hours worked. Alright? Hours worked can never be negative, hopefully. It can never be negative.
And the cost can be more, or can't reasonably be more.
Well, that's different, isn't it? So I'm talking about domain. So the domain would be the hours that I would work. Now, if I'm paying per hour, what also that limits me to only being able to use whole numbers of hours, right?
Oh, yes.
So I can't, like, if I work 1.5 hours, I expect paying for
1 hour.
2.
Yeah, you can't do that.
I've done more than 1 hour, you've got to pay me for 2. If the job's done in less than 2 hours, you still have to pay me for 2. Yeah? Yeah. Otherwise I stop at 1 hour and the job doesn't get done. But there's a situation where only whole numbers are possible to use. So the domain can be limited. Yeah?
If you're getting paid by the hour
Yeah?
and you finish up like you said, 2 hours, you do 1.5 hours, you can't get paid for 2.
Why?
You're getting paid by the hour.
So what would you do at the end of 1 hour if that was the case?
I'd give him an hour and then half
Yeah.
what he makes per hour.
Well, no.
But what if he
Well,
said you
I
pay
think-
per hour?
I
If
think
you
we're
pay
getting
whole
confused.
hours.
I think we're getting confused on one. Like, are you saying you complete your job in 1.5 hours, and
Yes.
you're supposed to complete in 2?
I'm
In
thinking,
that case, I would pay you
wages.
2 hours. But I was thinking if you're just working
Yeah,
at
like
Subway
I'm
or
thinking
something.
wages.
Yeah, then you just
And you
left.
Oh no, no, so the situation is,
Yeah, like $1.
you get paid per hour.
$1.
If I'm there for 3 hours, you pay me 3. But if I have to be there for 3.5 hours, we basically say you're there for 4. And you might go, well, I'm paying you for 4, so you're going to hang around and sit there for half an hour, right? You're not allowed to leave, just in case I have something extra for you to do. But that's a situation of function where the domain has to be whole numbers, because it's in context. So negatives sometimes are not an issue because of context. Decimals can't be used because of the context it's in. So the domain, quite often the domain of a function is anything. You're allowed to use any x values. But some functions you can't. Some functions, depending on the context, are not allowed to be used because they don't make sense. So the domain are the x values, and you have to be able to state what domain we're working on. Sometimes domain can be limited purely because the question says the domain of the function is, I'm only interested in between 2 and 5, right? And then that leads us into what is the range of the function. What do you think the range of the function is?
The difference in the numbers.
It's not quite the same as that range, no. What does it make sense? If the x values of the
The
domain,
amount of
The
numbers
range
or
of
the
numbers
value of
allowed
numbers
to
that you can use?
The amount
No.
of numbers allowed. The range of numbers that will be substantial for use will be possible in the domain.
what do you mean possible? Whenever we've been dealing with functions, we have an input and we have a...
Output it.
So what do you think? If the inputs are the domain, the range is going to be...
Output it.
Yeah. So The range is all possible
Y values.
outputs,
Okay.
right, which you would say y values from the given domain. So this is where I say the domain are the values that you choose. You might be limited, but you pick the x values. I know when I start talking about graphs and things like that with younger students, and they say, "Oh, but why did you pick 1 to go in for x?" And I'm like, I don't know, just did, you know. I picked 1, 2, 3, 4, and I drew a graph. Yeah? Well, why did you pick 1 first? It doesn't matter. You could pick 6 if you like. You end up with the same graph, right? Go on.
If your possible x values are like 2, 4, and 6,
Yeah.
for the range, would you write 2, 4, 6, or like
Okay.
2?
Yeah. So that's a very, very good question, actually.
I also,
Well, let me answer that one first, then we'll come back. So, for instance, let me explain. So, let's say we have a function. So, my function is f of x equals 2x plus 3. All right? I will say that the domain of this function can be written like this. What does that mean to you?
That x has to be a real number.
So x is a real number. What are real numbers?
Any number that is positive. No, any number.
Any number. Any number that you can
Any
put
number
on
on
any number that you can
Right there.
any number that you can put on a number line. Okay?
Wait,
No.
so
all numbers.
so that's
Every number.
Every decimals.
Every number
Unless
put on
you-
number line.
Once you get beyond what you're doing now, which hopefully some of you will, if it's not a real number, it becomes it
An
must be
imaginary
an
number.
imaginary number. Do you know what imaginary numbers are?
it's an I.
It's
It's
I.
a little cursor
And do you know
I.
what? So real numbers.
I know what it
Most people say, well, every number's a real number. Because pi is real, e is real, 1, 1.8, everything's real. However, we have I, which is imaginary.
I remember a great example of this.
And what is I? Go on.
Like, an example of I would be like the square root of -2 or -4.
Square root of -1 is I. Now you're going to tell me, but you can't have the square root of negative numbers.
That's why it's imaginary.
Hence it's an imaginary number. Now you might go, but that's useless. However, the square root of -1 is vitally important in engineering and electronic systems and all that kind of thing. So when you get up and you start dealing with complex numbers, because complex numbers use an imaginary part and they have a real part and an imaginary part, and you start working on them, you can't do an awful lot of engineering things without the square root of -1. But that does give us a reason why there are real numbers. Because we say, well, if everything's real, why bother calling them real? But there are things that are considered not real. So, but in this case, because we're not dealing with imaginary numbers, we just have real numbers. Now, if I then said the domain is this, what is the range? So I'm saying y, and I'm also going to say y is any real number as well. Why would I say that?
Because if the input is a real number, then the output must be a real number.
And how do we know that?
Because there's no input that you could possibly put in the whole world that would get I.
But let's not focus on the imaginary bit. In fact, I'm going to delete this imaginary bit. Let's completely forget. We don't even need to talk about it. I only talked about it because to explain why we call things real. Why can I say the range is anything? Yeah.
Oh, I was gonna do that. I had a different question.
What's your question?
Well, if there's y values, is that only in linear usage?
You can plot any graph, can't you?
Yeah.
So let's just talk about this one. So what I say, the nice way to then start looking at this is with a graph. Okay? So if I were to graph Come on, click. Oh. Sorry. I'm going to go back to the simple stuff. If I were to graph, sorry, y equals 2x plus 3, what does it look like?
So, 2.
Rise 2, run 1.
Just generally it goes like that, yeah?
Rise 2, run 1, and then it goes to
And how far does that line go?
Forever.
Infinite.
It goes on forever, up
both
and down.
sides.
So here's the thing. If I pick any x value, okay, if I read down, I get the y value, yeah, that goes with it.
Yeah.
Okay. Is there any y value that will never happen? If I pick the right x value, I will get every y value going, yeah?
Yeah.
Yeah, I can solve. There is no value of y that I can't have. So I can say that I'm allowed any x value, I can stick any number into 2x plus 3, and I will get any y value out. Now maybe this will help explain it a bit better. What if I then... Oh, come on, stupid. What if I asked you to consider a different function? All right? And I asked you to consider one of the other ones we were looking at, which is, what if g of x equals x squared plus 2? So just quickly, because that's 2 minutes to go, what is the domain?
The domain,
That is any x.
Equal to a real number.
Any real number. Because there's no value of x you can't put in. Okay?
yeah.
What's the range?
Range is all numbers.
Any output. Any output. So any real number.
R.
No.
Oh. No,
Y.
any real numbers.
All positive numbers.
X
No.
squared
Y
plus
is equal to
2.
an integer.
No.
XER.
That's the domain. X, E, R. X is an element of real numbers. X can be anything, but what can Y? Y.
Which numbers bigger than 2?
Y has to be greater than or equal to 2.
Oh yeah.
We can say Y can be any real number but greater than or equal to 2. Do you know why?
Yes.
Because if I were to draw the graph of y equals x squared plus 2, it looks like this, right? That's x squared plus 2. Where does it cross? At 2. It will never go below. It, however, will go on up for infinity.
The lowest that it can go is 2.
The lowest that we'll get to is 2. So the range of this function
is 2.
is not anything. Okay? It's 2 or higher. Okay? So the difference with domain and range is, in this case, I can stick any x value I like in, but the range is limited. You can't go below 2.
Okay.
Alright? Yeah? So, you will be expected, guys, you will be expected to be able to state the domain and range of any function, which means you need to be able to look at a function and know the shape of its graph. Otherwise, you're not going to be able to find the domain and range. Then we're going to have to solve and substitute and everything to be able to figure out this. Carry on with it tomorrow.
Here's my book saying.
Oh, yeah.
Yeah. Yeah.